right, good morning, guys. We have 3 things to get done today. We need to finish the notes on 2.5 and work on some of your practice. Worksheet 10 is part of the homework check. It's just 10 graphing problems. And we're just I actually picked 3 already that I thought were pretty hard, that we will get through those together as practice. And then you will have 3 less things to do on the homework check. And then we need the last 15 minutes to go over the 15, yeah, should do it. We have a couple examples we're supposed to start today on worksheet 11. Tomorrow, before I forget to tell you this, tomorrow we will have 20 minutes to ask questions about the quiz on Friday, but the rest of the hour we are taking notes, okay? Because everything on the quiz Friday is old except for 1 new topic. Does that make sense? You pick up the review in the back? Everybody got it? Okay. So that's the plan. All right, great. This is not getting the whole picture now. Is it not? You can move this. Okay, that was just add a page. I'll be all right. Can I not move this when it's running? Ooh, now it just moved. Okay. I don't know. All right, so worksheet 9, these are the learning targets we were working on yesterday. And these are the things we talked about. I am not going to revisit that other than to go through it on an example. We did those in this class yesterday. I'm not sure all the classes finished. We're going to talk today about a weird end behavior when it is top heavy, okay? Last year you got to write no horizontal asymptote and that was it. This year you're going to have to divide it out and find the end behavior function, whether that is an oblique asymptote or some other function. And it is on Friday's quiz. It's not graphing, you don't have to graph anything, but you got to be able to do the division. All right, so I mentioned this yesterday. If you have 2 vertical asymptotes, there has to be 3 parts to the graph. Everybody awake and get that, what I'm saying? There's something on either side of the vertical asymptotes. If you don't see it, you got to change your window. All right, one more time. End behavior asymptote is simply a way of combining the idea of oblique asymptote or whatever. So when you hear me say that, that's what that means. This is an example that you don't have. Does that sound right? Don't have that one? Okay, it has 2x cubed over x squared plus x minus 12. The denominator factors x plus 4, x minus 3. So there are vertical asymptotes where, guys? Yeah, domain restriction is x cannot equal negative 4 or 3. The vertical asymptotes are at x equals negative 4 and x equals 3. So there are 3 parts to this graph because there are 2 vertical asymptotes. X-intercept, anybody? Look at your yellow sheet. X-intercepts are also called zeros. How do you find them? Please use the yellow sheet today so that you're comfortable with it. Yes, at the top equal to 0. So when does 2x cubed equal 0? Yep, so it goes through 0, 0. Okay. Y-intercept is what you get if you put in a 0. Guess what we get? 0, 0. All right. Then the next thing is the end behavior. This is top heavy. So what is the rule for top heavy? Okay, it says no horizontal asymptote, but that is not the answer. Because what does it say underneath that? Yes, it says end behavior or oblique asymptote, and it says divide, ignoring remainder. Is that what it says? Something like that? Okay, so I'm going to do this for you for fun. This is this messy problem. Remember the top was only 2x cubed? But the good news is, guys, you get to ignore the remainder, so this isn't as messy as it seems. What do I multiply x squared by to become 2x cubed? 2x. Then if I distribute it through there. I get 2x cubed plus 2x squared minus 24x. Change signs and add. I have a negative 2x squared plus 24x. What do I need to multiply by now? Just a negative 2. So I get negative 2x squared minus 2x plus 24. Does it matter what happens here? If I change signs and add, I get 26x minus 24. Is x squared going to become an x? No. So this is remainder. So the end behavior function is going to be y equals 2x minus 2, which is in fact an oblique asymptote. If you graph this, I'm not going to take time to do it, but let me show you. If you graph it, okay, let me bring that to the front. Just kidding, where's, oh here, order. Okay, this is what it looks like. There is a vertical asymptote, you told me at, what was it, guys? -4 and +3, okay? And then there's this little cubic thing going through here. The end behavior, do you see out on the ends that it's going oblique? Okay. If I were to put in here, let me show you. If I were to put in that, which you can't see. Well, maybe you can up there. It's really hard on my screen. I'll do it in blue. If you were to put in this line, that's the end behavior it is approaching as it goes further left and further right. It's going to hug closer and closer to some oblique line. All right. Undo, 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 undo. So that is the end behavior. Not what I meant. Undo, move that. So that's the end behavior. By the way, this is what that graph looked like when I did a Zoom 6. So I had to change my window because I knew there was something else going on somewhere. Okay? All right, we'll do some together today. I don't want to take time to do that one on the calculator. All right, we started talking about holes vaguely yesterday. Okay. A hole is when the top and bottom have the same factor. Two important things. When there is a factor common top and bottom, you must first put down the domain restriction. You see that on your sheet? It's listed ahead on your yellow sheet. Domain restrictions are listed before holes and vertical asymptotes, right? Isn't domain restriction at the top, or does it not list it at all?
It says always factor P and Q first. Domain and all real numbers.
Okay. So number 2 is the domain, right? Or something. So you find that domain restrictions first. Then you're allowed to cancel that factor that's part of the hole, because there's not a vertical asymptote if there's a hole there. Okay? There's not a vertical asymptote. There's only a hole or a vertical asymptote at a point. So if I had this, okay, the domain restrictions would be x cannot equal -1 or 5 because of the denominator. Everybody good? Then you would cancel this, but you would say I was able to cancel x equals -1, which means there's a hole at -1, comma, and it says right here, set the canceled factor equal to 0 and solve for x. That's where your hole is. But then, I love this line, plug that back into the beautifully new simplified equation. That's this one, after we canceled. If you plug a -1 in right here, what are we going to get, guys? 0 over 0. So you have to plug it in after you divide it out. Now if we plug a -1 in, we get -3 over -6, or 1/2. And that's where the hole exists, okay? All right, did we do this question yesterday? Or we didn't, I feel like I didn't finish. Okay, so I don't think I ever got to it in the other two classes. So I'm gonna real quick get us back where we were. It factored x minus 7, x plus 3 on the top, guys. Does anybody have that? To factor the denominator, remember? Anybody remember how we did that? I said just type in y equals x cubed plus 2x squared minus 5x minus 6 and find the zeros. The zeros were at -3, -1, and 2. So we had an x plus 3, an x plus 1, and an x minus 2 as the factors of the denominator. Okay, so we just went over the order. You would first tell me the domain restrictions were where? -3, whoa, why do I have a parenthesis there? X cannot be -3, -1, and +2. Okay? The next thing it asks on a lot of the homework is for the vertical asymptote, or on the quiz, and a hole is listed very near there. Doesn't really matter what order you do this in, but there is not a vertical asymptote at -3. Why? Because it's a hole instead. Does everybody see that? Because it was the factor top and bottom. So the hole has -3. That means there are still vertical asymptotes at x equals -1 and x equals 2, okay? See how my grapher is working this morning. -1 and +2 are vertical asymptotes. All right, I need to finish finding where the hole is. So I put the -3 back in the reduced, the beautifully reduced, remember, equation? Okay, so if I put the -3 back in up here, I'll get -3 minus 7 over -3 plus 1 times -3 minus 2, which is -10 over -2 times -5, which is -10 over +10, or -1. Anybody get that? Okay, so at -3, -1 is a big old hole. All right. End behavior, and then we're going to have to refer to the calculator for the rest of this. Top heavy, bottom heavy, equal weight. I always look at the original one. The first one was bottom heavy, right? The original function. It still is, even if we divide that out, by the way. You have an x over an x squared. So what is the end behavior approaching if it's bottom heavy? Y equals 0, so there's a horizontal or dotted asymptote you should have here. What is weird about horizontal asymptote versus vertical? It can be crossed. Yes, we can cross a horizontal. Okay, I'm just going to say a little prayer that this is still in my calculator. I don't think it is.
Why do we find the horizontal asymptote if it can be crossed?
Because it's not always an asymptote. Sometimes it's a slant, not always horizontal, and it is what the end behavior is approaching as you go further left and right. So if I asked you the end behavior for that graph, you would tell me it's going to get closer and closer to 0. Okay? Can someone read me this disaster? It was x squared
Minus 4x minus 21 all divided by x cubed plus 2x squared minus 5 and then minus 6.
Oh, I didn't mess it up. What do you know? Assume 6. Okay. So there are 3 pieces. Does it look like our, what did we have, -1 and +2 as asymptotes? That looks pretty good. We didn't find the zeros or y-intercept yet. That was on me. The zeros are what still makes the top 0. After we've reduced, what makes the top 0? 7 would make everything 0. So out here to the right at 7, it actually crosses. And then the y-intercept is what we get when we put in a 0. I always go to the very original one, guys. Look at the original one. Wouldn't that become 0 and that becomes 0? Because you're multiplying by 0 if you're plugging it in. So I get negative 21 over negative 6, which reduces by 3 to 7/2. Anybody? I think I did that right. So it crosses the y up here at 3.5. All right. If you wanted to do a little better job, you could look at the tables. I'm just going to pull these up real quick. It does say it's undefined at -3 and -1. Okay. You can't rely on the table on Friday's quiz because you don't get a calculator. It also says at 1, it's at 3. You could scroll down and find some more points, but there's not really much going on. Okay. So a rough sketch where it's hugging that asymptote. It does look like it goes a little bit below that in my screen right here. Over here, it is hugging this asymptote. How do I know it doesn't cross over there ever on that side? We found all the x-intercepts already, right? And it only had one at 7. So while it crosses out here, it stays very close. That doesn't look very close. Okay, let me go back to the calculator one more time. If I trace left, it stays negative. Do you see that y is staying negative? Okay. If I trace, I'm going to go to the right and start at 7. There it hits, and then it goes above, but it stays very, very close to 0. Okay. All right. Any questions about that one? All right. One more example? Yes? Okay, here we go. Factor the top for me, somebody. Okay, what can you tell me? One thing, Brandon S. Tell me anything. Okay, good call. Top heavy. And I'll resort to leaving that for just a second. Jack, can you tell me one thing? Vertical asymptote, domain restriction, x-intercept, y-intercept. Got your little yellow sheet out? Xavier, can you tell me one thing? No hole, I like it. Hole, oh no. I don't even know what I'm trying to write there. Aislinn, can you tell me one thing? What kind of goes with that? The domain restriction is also all real numbers except -1 work then, okay? Vertical asymptote at -1, I'll go ahead and draw that. No hole. Okay, anybody got their sheet out? What else can you tell me? Haley? I need to find x and y intercept. Which would you like to help me with? X-intercept is when the top equals 0. So what would I get? Would it make a 0? And what else? -3 and +2 would both make the top equal to 0. Everybody okay with that? So 1, 2, 3 negative and 2 positive are x-intercepts. Y-intercept, Destiny?
0 negative.
If I put in a 0, I always go back here, guys. Isn't that the easiest place to put the 0 in? You just get a -6/1. 1, 2, 3, 4, 5. Great, it's off the bottom, right? Okay, that's the y-intercept down there. If I were to extend this a little bit, it would be down there somewhere. All right, that just leaves our end behavior. And this was top heavy. What does it say for top heavy? It says no horizontal asymptote. Do not ever give that as your only answer. unless it's specifically asked, okay? Only for horizontal asymptote. What are we gonna do? What's underneath that on your sheets? P over Q. We need to divide. Do we need to do long division for this problem? No, because the denominator is just an x plus or minus c constant. So we can do -1 in the box, 1, 1, and -6 across. Bring down the 1, multiply, add, multiply. That's 0 sometimes. Add. Okay. This is what? The remainder, which it says to ignore. This is a constant, and this one gets an x. So the little baby equation is just y equals x. Y equals 1x plus 0, if you want to write it that way. Okay? Yeah, it would start at 0, go up 1 and over 1. So that is our end behavior. What this graph is doing out on the far ends is getting closer and closer to that. Okay, then the last thing is you just throw it in your calculator. What are you going to type in your calculator, though? If you want to type the factored one, you got to do this with some extra parentheses. Actually, you don't need extra on the bottom. But I would never type in the factored one if they didn't give it to me as the factored one. I'd type in what they gave me, because then if you messed up factoring, you might notice it, right? When you typed it in, you were like, wait a minute, that's not where I said their asymptotes were. So I would type in y1 equals parenthesis x squared plus x minus 6 divided by parenthesis x plus 1. Okay, I did that, and I got this graph down here, which if I pick a lovely purple, which it won't let me do, maybe, I don't know if I got one, is getting closer and closer to the asymptote here, goes through this spot, and then goes this way and hugs. Yeah, clearly. Okay, that's supposed to be a smooth curve right there. Down here, it crosses at, oh my gosh. It crosses here. And then it keeps going up here, crosses, and eventually gets closer and closer to that asymptote and to the vertical one. Okay? Questions? All right, the bookwork on that is here. I expect to see all those things listed on the yellow sheets. Please don't just scribble down a picture, okay? There might be some that it says you don't even have to graph. It just says like where are the vertical asymptotes. I don't remember. So follow the directions. All right, we are switching now to worksheet 10, which is homework, okay? It says analyzing rational functions, and this is your homework. What time are we done? 23. So if I go back, say 13 minutes, I got about 8 minutes to do some of these. So we're gonna go fast. I would suggest we start with 4. Can we start with 4, guys? I picked some hard ones. Factored form. Please be doing these because this is on the homework check. If I take out a 2, I'd have x squared minus 4, which would then factor. Okay? What about the denominator? Okay? Before you talk about the whole, because there's definitely a whole, what do we always have to write down first? The domain restrictions are at x cannot equal -1 and -2. Okay, is there a vertical asymptote at -2 though? No, because instead there's a hole. Okay, -2 is a hole. The vertical asymptote is at x equals -1. Everybody okay? Now, I'm going to draw that badly. You know what? I'm going to cheat. -1 is a vertical asymptote. Okay, I don't know why I got weird ends on it, but that's okay. It's a line. It's a vertical asymptote. Yep, it's not working up there anyway. And my little boxes. There, that's better. All right. We need to finish finding the hole. How do we do that? The beautifully simplified equation. Cross those out. Now when we plug it back in, we have a 2 over -2 minus, or times -2 minus 2, all over -2 plus 1. Remember, we're putting in -2. This would be -4 times 2 is -8 over -1 is +8. So -2 +8. Nice big hole, and mine doesn't look like a hole because it didn't write where I wanted it to, but hopefully we'll be okay. All right, what's next on the yellow sheet? Let's go down in order. We did domain, we did vertical asymptote, I did. Zeros, okay? Zeros or x-intercept. How do we do that? Okay, somebody's going to get this wrong. Does this 2 out here do anything? Can't equal 0, but what would this be to equal 0? Still would be 2. So a 2 would make us come out 0. So at 2, 0, there's a 0. It's the only x-intercept. Y-intercept, you put in 0. I'm going to go back to the original one. If I put a 0, 0, 0, I'm going to get -8 over 2, yes? Crosses y down at -4. Okay, top heavy, bottom heavy, equal weight, I think is all we have left, right? Is end behavior? It is equal weight. So what is the rule for equal weight? Leading coefficient over leading coefficient. Go back to the original right here. 2 over 1 are the leading coefficients. So y equals 2. Remember, it has to be an equation. I'm going to attempt to use my line tool again. +2, yes. Y equals +2. Okay. Then I'm going to go to my calculator, and somebody's going to read this to me really fast. If I turn that one off and I go down, and, well, 2x squared minus 8. Like I said, I always just do the original one.
And then over x squared plus 3x plus 2.
Because if I go to graph it now, and the hole isn't where I think it is, or the vertical asymptote's not where I think it is, then I factored something wrong. What? Okay. So this is what I'm getting. Does that look like it would fit on our graph okay? Where was the hole at? 2, 8?
-2, 8, excuse me.
So if I try trace -2, enter, I should get nothing, right? There's a hole there. Okay. My window doesn't show it. If I trace to -2, it's just a hole. There's ways you could make the calculator show it if you set it to number of pixels. I'm not going to worry about it. All right, so we think this is all good? So, oh, we could have found one point over there, because I can figure out what this one looks like. But could you find me one accurate point over there somewhere to put down, just so I knew about where that guy was? If I trace over here, like -2. Oh, that's the hole. Thank you, Hofbauer. That was genius. -3 is at 5. -3, 5. Yeah, thanks, Hofbauer. That was really good. Negative 3, 5, and was it still going down a little bit after that?
Yeah.
And up this way. It will eventually get real close to that horizontal asymptote. All right. You do have to make it go through the hole though, right? Not like touch the hole, not actually go through the hole.
Line splits into two to make.
Yes. All right. I don't have hardly any time. All right. We can do 6 or we can do 9. 9 has an end behavior equation other than a horizontal asymptote. Which one, 6 or 9? Huh? 9? Okay. 9. If I take a 2 out of the top, I have x squared minus x minus 6, which would then factor x plus 2x minus 3. Does that work on the top? Does it have any holes? None. What do you want to do next? Domain restriction, since it isn't even listed here. X cannot equal. So there is a vertical asymptote at. Okay, I'm using freehand, so this is going to look really bad. Okay, x-intercept. Is this 2 one of them? No. The only thing that would make this 0 is negative 2 and positive 3. So it crosses the x at negative 2 and positive 3. Y-intercept, go back to the original one, somebody. Put in a 0 way back here and I get what? Negative 12 over 1 or negative 12, which isn't going to be on my graph paper. Okay, does it have a horizontal asymptote? Top, heavy. Yep, so none. It does not have horizontal. Oh my goodness, I don't know what that says. So none, but it ran over. Top heavy, none. Okay, slant asymptote. How do we find it? We have to divide. We can do synthetic. The original polynomial was 2, negative 2, negative 12. We don't need any zeros. Bring down, multiply, add, multiply. We don't care because it's a remainder. So I got this. Did anyone else get 2x minus 4? So can we accurately graph that real quick? Go to 4. Up 2 over 1, no. Up 2 over 1, up 2 over 1. Yep, I'm not getting anything accurately graphed with my slate today, but this is what it looks like. What? So the graph I'm thinking is here. And here. And I would check that by putting it on the calculator. I would type the original one here over this one with parentheses. Is everybody okay if I stop there? Okay. I have very little time left, but I would like to talk about the front side of worksheet 11. Okay, do you remember at the beginning of the year we did questions like this? What did we do to get rid of the fractions? Multiplied by the least common denominator. Yes? That's what we're going to do today. Okay? This is an example on worksheet 11. It says x minus 8 over x minus 4 equals 11. What is the common denominator? X over 8, minus x, 8 over x minus 4 equals 11. What's the only denominator other than 1? So we're going to multiply each piece by an x minus 4, which is done for you right there. It's written out. So now let's finish. What is x times x minus 4? Okay. But what happens to this second one? The x minus 4 and x minus 4 divide out, so we have minus 8. Equals, on the right-hand side we have, okay. Now, we got to this point on the last quiz, and some of you tried the craziest things. What should you be doing right here? Get it equal to 0 and factor or solve somehow, yes? I got people doing some crazy business. X squared minus 15x plus, I don't know, 36, which factors x minus 12 and 3. Then they both have to be minus. X minus, oh, my tablet doesn't work down there. X minus 12 and x minus 3. X equals 12 or 3. All right. There can be extraneous solutions, guys. The extraneous solutions are simply any ones that would make the denominator 0. You really should check your entire answer, but do either one of these make the denominator 0? What is the one thing we can't have here? X couldn't be 4, but we didn't get that as one of our choices. All right. I'm moving on to this question. This is all written out for you. Everybody see this one? Is it all written out for you? They picked the denominator. Look at how messy this was, guys. There was a 3 and an x minus 2. Then there was a 6 and an x minus 2. The common denominator had to have an x minus 2. But it also had to be divisible by both 3 and 6, so it was easier just to use 6. Now, I wrote it out down here. I'm not going to do the whole problem, but do you see what happened here? The x minus 2 divided out. The 3 divided into the 6 up here twice. So you would end up with 2 times x plus 1. Here, only the 6 divides out. So you had a 5x and an x minus 2. And back here, the x minus 2 dropped out. 6 times 1 is 6. So then it turned out to be a quadratic. They got solved like this. They got 2/5 and 2. What was wrong? Yeah, x can't be 2 because this was part of our denominator. So the only solution was 2/5. All right. We're going to do number 1 and beyond, hopefully. Okay. What is the common denominator here, guys? This is the easy peasy one. The only denominator is m, right? So we're going to multiply all the way through by an m. So I'm going to write 15 over m minus m plus 8 equals 10. And I'm going to multiply everything by an m. I probably should have moved the 8 over to the 10 or the 10 over to the 8 first, do you think? Would have been a good idea. Saved a little bit, but it's okay. What do I have now? 15 minus m squared plus 8m equals 10m. Now what? Can I move everything to the right? Because I don't like a negative on my m squared. So I'm going to make 0 equals, if I add it to the other side, it's a positive m squared. But then I'm taking away 8m's, right? And taking away the 15. Does anybody else get that? My signs are right, okay? That factors m plus 5 and m minus 3. So I get m equals what? Negative 5 or 3. Either one of those I have to throw away? Nope. Okay. You should take time to check them. If you do put in a negative 5, you get negative 3 plus 5 plus 8 equals 10. Does that work, guys? 13, yeah, that works. If you put in a 3, you get 5 minus 3 plus 8 equals 10. Does that work as well? Okay. All right, here we go. Last one of the day. Common denominator has to have both what? A b and a b minus 3. A b times a b minus 3. Everybody okay? So I'm going to write the original problem down. And then I'm going to show that I'm multiplying each piece by both a b and a b minus 3. A b and a b minus 3. A b and a b minus 3. Okay, can anybody tell me what happens? So I end up with what for that first term? Okay. Then what? Yeah, can I distribute at the same time? That's what Martin suggested. So 3b minus 9, everybody okay right there? You could definitely write it down and then distribute it. And back here? I got a, oh, was it negative in the original? Mine is covered up there, so it is negative 2b squared. Thank you. All right, I'm going to add the 2b squared over here. Add my 2b terms together, so I get 7. Oh dear. Well, oh, I think it's going to factor 9 and 1. B and B, 9 and 1, positive 9, negative back there. Does that work? 2b squared plus 9b minus 2b would be 7b minus 9, yeah. So I get b equals negative 9 halves, or b equals 1. Either one of those have to go in the garbage? What are the two things b could not be from our original? 0 and 3, and we didn't get either one of those, so both of these work. Okay? So I wouldn't worry about this homework assignment yet tonight. Just worry about the rational function, because this concept is not on the quiz, okay? This is part 2, or 2.5b is the standard here. So what is it I want you to do tonight?
Not this.
No. I want you to work on the 2.5 bookwork, which is page 138, and worksheet 10, and look over the review, because I am only going to spend 20 minutes on that review tomorrow, because the rest of the time we need to finish this notes worksheet. Everybody good? Let me see if I can make this stop recording.